A photovoltaic system is made up of panels which produce DC power when exposed to sunlight, and an inverter which converts the DC power into AC power that is fed into the utility grid. In commercial rooftop and ground mount PV systems, there are three different inverter topologies: a central inverter, a traditional string inverter, and the SolarEdge solution. Let's first take a look at central inverters. Central inverters have expensive maintenance contracts and can only be serviced by specialized teams. This leads to high operating expenses. In addition, energy harvest is optimized at a full array scale, leading to mismatch-related power losses, and every inverter malfunction results in full array downtime. For these reasons, decentralized architecture that uses multiple string inverters instead of central inverters is gaining market share. String inverter topology allows higher system availability, lower land use, and lower operation and maintenance expenses. While central inverters are typically used in ground mount installations, string inverters are used in both ground mount and rooftop systems. Although traditional topology using string inverters is still used in the majority of large-scale installations, it suffers from a number of significant drawbacks. First, the system power output is limited. In traditional systems, panels are wired in a series as a string. Each panel has its own power production profile. This is a function of its manufacturing variables, installation parameters, and shading patterns. This means that panels don't usually work at their maximum power point. Second, the traditional system has design limitations. Strings are shorter, and all strings connected to the same inverter need to be at the same length, use the same type of panels, and be positioned at the same angle. Real-life installation constraints, especially in rooftop systems, result either in wasted roof space or unnecessary duplication of balance of system components. A third drawback is safety issues. The DC cables that connect the panels to a string carry high voltage as long as the sun is shining. The traditional inverter cannot shut down the DC voltage of the panels, and therefore there are serious associated risks for installers and firefighters. And lastly, a traditional system cannot track power output, temperature, or any other parameter of a single panel. This makes it impossible to identify specific panel-level problems remotely. When we started to develop the SolarEdge solution, we looked at the challenges posed by traditional systems and defined three goals: to optimize and monitor power generation of each panel, to use the same installation methods and components used to install traditional inverter systems, and to minimize long-term operation and maintenance costs. So, we developed a topology that meets all of these goals: the SolarEdge DC Optimized Inverter Topology. Our solution splits the traditional inverter functionality into two products: the Power Optimizer and a simplified inverter. The power optimizers are located on the panels, turning them into intelligent panels.